Hello everyone, in this video we are discussing two important theorems from circle chapter. From circle chapter there are two theorems are there. Out of two, one will ask for 3 marks question. So theorem 1 of this chapter statement the tangent at any point of a circle is perpendicular to the radius through the point of contact. So figure O is the center of circle and I am drawing one tangent xy. xy is a tangent drawn and its point of contact is P. So given O is the center of circle and xy is a tangent and P is point of contact. So what you have to prove? You have to prove tangent and this radius OP is the radius and XY is the tangent. These two are perpendicular to each other. To prove OP perpendicular to XY. This is also having construction. So to prove OP is perpendicular to XY, I have to prove this is the shortest distance. This radius is the shortest distance to the tangent XY. For this I am taking any point Q on the tangent XY and join OQ such that this OQ touches the circle at R. This is the construction. Take Q on XY other than P and join OQ such that it touches the circle at R. This is the construction. So now proof. See the proof here. Here I draw the other point Q than P. So OQ is a line. So OQ is a line. How you got OR plus RQ? Correct? So OQ is equal to OR plus RQ by construction. So by construction I can write OQ is equal to OR plus RQ. So from these two, this is one complete whole and these two are the part. So we know that whole is always greater than the part. So OQ is greater than OR. Understood? This is one complete whole. This is get by a combination of two parts. So this whole is greater than a part. So OQ is greater than OR. Here OP and OR are both are radius. We know that radius of a circle are equal. So in the place of OR I can write OP. So OQ is greater than OP. Since OR is equal to OP, both are radius of a circle. So OQ, I taken one point Q on XY. What I got? OQ is greater than OP. If I take any other point, let us take here one point M. So if I draw OM, again I will get OM is greater than OP. So if I take anywhere point on this XY, I am always getting that point distance from a center is always greater than this OP. So what happens? This implies OP is a shortest distance from XY. So why this happens? This happens in every point other than P in XY. So this is the shortest distance means this implies OP is perpendicular to XY. Hence the theorem is proved. Next to theorem 2 statement, the tangent drawn from the external point are equal. So I am taking a circle with the center O and P is one external point. What I have to prove? Tangent drawn from the external point. I am drawing PA and PB are the tangent from P. What I have to prove? I have to prove tangents are equal, means PA equal to PB. I have to prove. So what is given? Given PA and PB are the tangent drawn from P to a circle with center O. It is the center O. What I have to prove? I have to prove the tangent drawn from the external point are equal, means PA is equal to PB. I have to prove. It has one small construction. If you are writing or you are not writing, it doesn't matter. So join OA, OB and OP. Join OA, OB and OP. After joining all these three, you can see two triangles here. One triangle is OAP, another triangle is OBP. So in the proof, in triangle OAP and OBP, in these two triangles, what is common? OP equal to OP, common you can see here. So OP is equal to OP, common, and OA is equal to OB, both are radius, and angle B is equal to 90 degree, angle A is equal to 90 degree. Angle B is equal to angle A is equal to 90 degree. This is a radius perpendicular to tangent. This is from theorem 1. By that implies triangle OAP congruent to triangle OBP. This is by RHS congruency rule. You have to mention RHS because 90 degree hypotenuse and one side is there. So you can't mention SAS. This is by RHS congruency rule. These two triangles are congruent. If two triangles are congruent, corresponding parts are equal. So PA is equal to PB. Last two letter PA equal to PB, CP, CT.